YouTubers, just want to show you my next project. This is basically a miniaturized rotary phase converter. Okay, now I have a 60,000 RPM brushed motor. Now this can run AC or DC depending on if the bridge rectifier is hooked up or not. I got a little resin fiberglass pulley I made. It's not perfect, but it's pretty true. And I really like this motor. I mean, everything's awesome. You know, it's got these brushes that when you push inside of its housing, there's these two contact springs right here and right here, where these brush pads just kind of sit and rest on, and it just pops right in just like that. You know, it's perfect, and there's hardly any friction. Anywho, I can't take this off here because I have everything resined in. It's all resined in. I can't take it apart, but inside of here, if you can see anything, there is a squirrel cage rotor, which I had cut slots into and wound just like a cylindrical rotor inside of a larger, 150 kilovolt generator, like a gas turbine generator. Same type of setup, just miniaturized. And that's a 3-phase stator. And here's all my lines. There's the neutral phase. Neutral is the blue. And then I have the orange, red, and gray for the 3 phases. Okay. Now I have this wound in series. So basically, your DC goes in here. Okay. Positive, negative. And I put a little switch here so I could manually turn it on and off once I have it wired. You know, it's kind of whatever. But anyways, so what happens is the current runs DC to the motor, through the motor, out the motor, into the brush on the generator, out the brush on the generator, into the core, which rotates and sends magnetic field rotating, which intersects the stator windings. You know how a generator works. So basically the voltage goes in right here, 5 volts or however many volts I want to turn this motor. Unfortunately, I don't have a variable control. I kind of wanted to synchronize this, so I wired them in series, so as I turn the motor up, the voltage automatically is synchronized to the generator. So if let's say I got a rheostat and I hook up, you know, a voltage supply, and I start with 10 volts, I'm also doing 10 volts of excitation to this rotor. So 10 volts spinning, 10 volts excitation. Okay, now if you're confused, this is the whole reason. It's synchronized not only by the electrical flow, but by the turning. Now I have a different ratio, so this turns once, this turns like 6 or 7 times. So 1, 2, 3, 4, 5, 6, 7 rotations per 1, 7-to-1 ratio. Now I know I might not need that much excitation voltage at first, but I figured, you know, why not? You know, as fast as I crank up this guy, 10 volts, 10 volts excitation, 20 volts. Let's just say 10 volts, 10,000 RPM. 10,000 RPM would be 70,000 RPM, 70 to 1. And then you have 20,000 RPM, which would multiply that even higher. So every time you go up in voltage, you not only go up in RPMs, you go up in excitation voltage, and it's all synchronized. So I go up 10 volts, 10,000 RPMs, or I can go 20,000 RPMs at 20 volts, or 30 volts at 30,000, or 40 volts at 40,000, and so on, so on, so on. So I wanted to miniaturize basically what they use already at the damn General Electric plant. Okay, it might not look all sexy, but you know, you got your prime mover, you got your 3-phase converter, and your 3 phases here. You can run 3 different machines or run them in series, whatever you want to do. There you go. I have yet to fire it up, but I've tested all the contacts and it runs fine. I've tested this without the motor and it puts out at least 200 volts with 5 volts excitation. I haven't even tested it at 10 or 15 volts. I'm actually kind of scared to do that because the wiring is so thin. I'm afraid it's going to burn out, but I'm pretty sure I have it nice and resined in, so there's not going to be any shorts to worry about, any you know, shorts or burnouts or anything like that. So I'm pretty confident with this machine here, guys, and I'm just very confident. You know, it spins true. I've spun it up and it doesn't slip or anything, and this thing I've tested ridiculous, you know, before I even put it together, so I know this works, and I have it running in series. Anywho, that's pretty much what I got to show you. I'll let you know when I hook up a big battery to it and see what kind of voltage I get off of it. Till then.